In 2016, during a game of Go, a move was made that puzzled the world's greatest players. It was move 37. To a human master, it looked like a mistake, a novice's play on the wrong line of the board. Commentators were baffled, calling it very strange and uncreative. Lee Sedol, the 18-time world champion playing against the machine, left the room for 15 minutes to process what he had seen. He wasn't just facing a competitor, he was facing something that didn't think like a human. The move wasn't just good, it was profoundly alien, a glimpse into a strategy that had never emerged in 3 millennia of human play. How can a machine learn to be creative? It doesn't. It learns value. An AI like AlphaGo plays itself, not once or twice, but millions of times. Each game is a life cycle of trial and error. Initially, its moves are random, nonsensical. But after each game, it adjusts its internal network, reinforcing connections that led to a win and weakening those that led to a loss. This process builds something called a value function, almost instinctive ability to look at any configuration of stones and assign it a single number, its probability of leading to a victory. It isn't calculating every outcome. It is developing a feel for the game, a purely mathematical intuition. This is fundamentally different from older game AIs. When Deep Blue defeated Garry Kasparov in chess, it was an act of brute force. It calculated 200 million positions per second, a computational blizzard that overwhelmed human capacity. AlphaGo, by contrast, examines 1,000 times fewer positions. It doesn't need to check every possibility because its value network tells it which paths are not worth exploring. It's the difference between reading every book in a library to find a fact versus knowing exactly which book and page to turn to. One is calculation, the other is a form of learned wisdom, a statistical ghost of understanding. The alien nature of Move 37 comes from this process. Human strategy is a cultural artifact passed down through generations. We have biases, traditions, and schools of thought about what a good move looks like. The AI has none of this. Its knowledge isn't derived from human games, but from the fundamental mathematics of the 19x9 grid and its rules. It discovered principles of Go that were always there, but were obscured by our own history and cognitive frameworks. It explores the entire possibility space of the game, not just the small corner that humans have inhabited for centuries. This feel is then combined with a more targeted search. Think of the future possibilities of a game as a dark, branching forest. Brute force tries to turn on a floodlight and illuminate the entire forest at once. Reinforcement learning, using a technique called Monte Carlo tree search, works more like a flashlight. The AI's intuition points the flashlight down the most promising-looking paths. It runs thousands of fast, simulated games down these paths to see where they lead. If a path looks good, it explores it more deeply. If it looks bad, it backs up and points the flashlight somewhere else. It's a powerful combination of gut feeling and focused exploration. So, where does the AI think? It thinks in a place we can't visit, called a latent space. Imagine a space with hundreds of dimensions, where every possible concept in the game-like good corner position or weak connection is a direction. The AI plots the current state of the board as a single point in this high-dimensional space. Its thought process is simply moving from one point to another along a trajectory that it has learned leads to victory. We can see the inputs and the outputs, the move on the board, but we cannot truly comprehend the geometric reality of its decision-making. It is a form of reasoning completely alien to our own narrative, cause and effect experience. When an AI plays a game, it isn't playing against us. It is holding up a perfect mirror to the game itself. Its strategies are not a reflection of its own intelligence in the human sense, but a reflection of the game's pure, underlying mathematical reality, free from the filter of human consciousness. We didn't just build a machine that could beat us at a game. We built a new kind of microscope, allowing us to see the hidden depths in the systems we thought we had created and mastered. And it leaves us with a question. What other realities have we failed to see because we were only looking for reflections of ourselves?
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.